Hey, welcome back. I wanted to do for class assignment 9. I wanted to do like a part 2 here, a little follow up video, and it's just about keeping things like at accurate length. So it's funny. Like after I was done with that last video, I thought, oh, let me pull up some dimensions here and see how close I can because I didn't pull up these dimensions before I ended that last video. But what I found was when we just kind of use this bottom. I pulled from the node point here, and I pulled this circle with this with a radius between the node points. I used that to develop the 6 and 5/8 side of this cone, and then took everything to the apex. So what I ended up, as I did a little research here, I found when I took 12 of those across here, with the margin of error between each one, and the margin of error is a little bit because rather than when I took that development circle down here and divided this one by 12 and I established these node points, when I actually pull a circle to kind of make up the difference between those node points, it's slightly off. So what it ends up, the difference here a little bit is like this circle has a radius of 1.7147. If I take I'll bring up my calculator here and kind of show you what I'm thinking. Something that's, and I'm not dealing with any material thicknesses here. I'm just kind of dealing with diameters. So if I have something that's 6 and 5/8 in diameter, and I'm going to multiply that by pi, what I end up getting is like a diameter that's like 20.8131. And then if I divide that by 12, because all I've done, that would be like the circumference of 6 and 5/8. And if I've divided that by, I'm going to divide that by 12 now because in between my node points is so much of the circumference there. So if I just take this and divide by 12, I come up with like what the true radius would be of this circle should be, and it ends up being, instead of 1.7147, I end up with a circle that should be 1.7344, let's say. So it's actually that long between the arcs here, instead of just a straight line radius circle. So I can get a little more accurate pattern if I am dealing with actual numbers rather than just a quick reference circle. So you would see me maybe to do a more accurate pattern would use this number, which doesn't seem like a lot, but it adds up when I the way I did that on that last drawing. So let's take and use a circle this big, 1.7344. And so I've actually copied out the main information over here that doesn't have the finished pattern. And instead of grabbing a circle to represent that, I'll use the same like orange, and I'll do a circle. Only I'm just going to kind of just put one out here in space that has like a radius of 1.7344. And I get this circle that has the actual radius for the actual pattern size. So now, then maybe I'll turn that to a dash. Okay, good. Because it's just a reference circle. So now let's use this and pull the dimensions. See, what I want to show you the difference is, let me just do this first. I'm going to copy this thing. Same way I kind of finished off that last pattern. I'm going to do 12 of these across the same magenta outer line here. So there's like 1, 2, 3, 4, 5, 6. That's the halfway mark. This is, I think, where I switched up and did like a yellow line for the center line of this pattern back to the apex. And it could be on that first pattern that I didn't zoom in close enough to see if I had maybe missed my pattern a little bit. Maybe one of these I've misplaced. I don't know. I just think there's a little bit of error built into this by the way I did it the first time. So I just want to pick up 6 more of these on the other side of this pattern. So there's 1, 2, 3, 4, 5, 6. Okay. That should essentially be kind of a spacing that, that represents the true length. And now, I think when I finished this off initially, I just kind of went and said, from that's the end of my pattern now, back to the apex. I'm going to do that the same. And now I've kind of like ghosted in where my pattern lies now. So now what I'm going to do is I'm going to trace this again as a polyline like I did last time. I'm going to trace this pattern now and pull it out and kind of pull some measurements out of it. See if it's closer to the true lengths that I'm looking for. So now I'm going to arc and second point. That should be a dashed line that bugs me. Okay. That's center line anyway. I can switch it. And then back to a line here. So I just put L for line to transition this polyline back to and then do an arc with the second point as the center line here. Whoops, sorry, here we go. There. And back to this ending here. Okay. Let me change that to a reference line here. Okay. Good. Now let me copy this out. I'll even take it center line. And let's just see what this pattern measures. See if it's any closer. I'll get this back to true length too here. Give or take a little bit. Okay. So there's my pattern. Now what I'm going to do is I just pull like an angular dimension here. So I just come up to my dimension and annotation tab, and I'm going to pull, what I'm looking for is kind of like an arc length here. So I just want to measure this arc length, and maybe I'll do this with just a white line here, or white. So let's measure like this arc, and then kind of pull this out and see what it measures now. So it's just pulling like either side of this, pulling the same dimension between this arc. So that's 20.825. Let's like repeat that for this inside radius too. 11. So the initial pattern that I use with the stepped off circle ends up having a inside top radius, I should say, of 10.8749. And a bottom radius of 20.5846. So I guess my target actually is what I'm looking for, if I just pull these up on screen, might be the first one. I think we already did 6.625 times pi equals 20.8131. 20.8131. So with that up there, 20.82. So yeah, let's see here. I'm just kind of looking at my margin for error there. I'm only 6/1000ths off the pattern length on that one, so that one's really close on the side that I used to develop. That's I mean 6/1000ths with a welded part is ridiculously good tolerance, right? So so that is really close. Now, how close is the upper pattern? And because that's just one that I take back to the apex, and I don't even do the development circles around the upper pattern, which I could do. You know, I could totally step off from this point, its development circles around the top, and then get kind of a truer line. And so I'm not doing that. I'm just kind of taking an estimate by using just the base and up to the apex. So let me see what I get. You know, because if I pull up my calculator again, what we'd be looking for is the 3.5 inch. Sorry, let me clear that out. The 3.5 inch diameter up top times pi ends up being 10.9956 in the true dimension. So 10.9956, that is almost 11, right? So, And that's what I end up with this pattern over here that I just did. So it ends up being way more accurate the second way I did this, using an actual true length between my node points as my development circle here. Much more accurate than my other one. So I just want to point that out because that is virtually same margin for error, almost 6 thousandths. I'm just barely picking up 11. But the first pattern is significantly off. Like if I come back over here to this one, like this one is close, 8, 7 rounds up to 9. I'm pushing like an eighth of an inch off almost. Just about an eighth of an inch off the pattern. That's starting to be sloppy. And what I noticed is I didn't like about this is closer to a quarter of an inch off the pattern. So and that's in a small pattern. I mean, that's only a 6 5/8 small. So to me, there's something to be said by some of these hack jobs that were quick in the past with a compass and a pencil just to step off a distance can lead to some inaccuracies. And I think guys that used to do that factored that in with how they kept their pattern. They'd fudge it a little bit big when they actually kept their lines, like mark it out and leave the lines, and that would grow to be closer to true length. There was tricks that they would make up the difference with that, but if we're dealing and making cut files, even if I'm making these cut files by hand like I'm doing, I can get much more accurate if I just punch in, figure out the circumference that I'm really looking for, and then step off that distance, even if I'm still stepping it off, like use an actual dimension. So this was part 2 for this. It was just showing you how I may analyze and get a more accurate pattern. And, anyway. So this was just part 2, follow up on accuracy of patterns and margin for error. And sometimes some of the old hacks, or they're not hacks, some of the old tricks definitely had some bigger margin for error. And with AutoCAD, we can get a little closer if we're making cut files. We get really close. Even I can be closer out if I would just set my compass rate, instead of stepping off this distance with my compass, if I would actually just pull up a new circle and set my compass to an actual step-off distance that is accurate to the circumference, I can get my pattern accurate. So that's it. Little part 2 to class exercise 9 about accuracy of parts and patterns. So we'll see you in class assignment 10.